Okay, so Amrita, is it clear now? Is it sound is clear now? Is the sound clear? Sound issue. I think it should be clear now. Is it just let me know? Just let me know. Kanak, yeah, Kanak, very good morning to you. So I'm not able to see Kanak in the current affairs sessions. So I don't know why. So Kanak, you should be present in current affairs sessions as well. But nonetheless, geography session, start with geography session today. Okay, but also watch the repeated sessions. Okay. Amrita, okay, so yeah, good. All right. So features of planets. So Mercury, the smallest one, we talked about the smallest one, the fastest, and also in the one who does complete the revolution, the smallest amount of time, that is the 88 days. Okay. Okay. So Akareke, yeah, yes, okay, great, super. All right. So we talked about Venus also, and very few and very important things about Venus: Earth's twins, hottest planet, brightest planet, morning and evening star, veiled planet. So these are some few important things about Venus. So always remember them. Okay. So simple questions can come, and if you forget this, that will be a bummer. If you're not able to answer. Okay. Student prepare. Okay. Chala, superb. So we did Earth also, Earth, blue planet, watery planet in the Goldilocks zone. We all know that. So this is done. Yeah, Mars, we spoke about Mars a bit. Okay, so Mars is, it was billions of years ago wetter and it was warmer. We all know that. We spoke about that. We studied that. Okay, very important is red planet and iron oxide. So we are just revising it. Okay, we are revising it. We're quickly revising it. Then we'll move on. All right. So iron oxide, red planet, and Phobos and Deimos are two satellites of Mars. Those are important. Okay. Okay. So we also we spoke about Jupiter. We learned about Jupiter. Okay. Fastest rotational velocity. Just complete the entire rotation. We take 24 hours. This chap takes less than 10 hours. So it's amazing feat. 80 or so satellites. Okay. So Europa, Callisto, Ganymede, Io, four important ones. They're collectively called Galilean satellites, and Ganymede is the largest satellite, not just of Jupiter, but of the entire solar system. Not the universe, solar system. Okay, okay, so Jupiter is done. Let's see Saturn now. Saturn, a system of 8 rings. Okay, prominent rings. We will find Neptune and Uranus also having ring system, but very faint ring system, very faint. This is very prominent. 82 satellites or so. Highest number of satellites. Titan being the largest. So Titan being the largest. Okay, so these were some important things that we discussed about the planets till now, about the universe till now. From now onwards, we want to see what's we have for today. Okay, so Saturn is done. Still Saturn it was done. Now yes, Uranus. Okay, Uranus is green in color. Very important point to note. Earth is blue in color. Mars is red in color. So Uranus is green in color. So very important. They might ask you a simple question: which of the following planet appears to be green in color? So simple questions, simple options, and if you don't remember it, it becomes very difficult because you won't be able to answer, and then you'll cry. It's such an easy question. Okay, so Uranus green in color because of the presence of methane in the atmosphere. Because of the presence of methane. What else has methane? Titan, the satellite of Saturn. The satellite of Saturn also has methane. But in what form? A liquid form. In what form? A liquid form. In liquid form. So CH4 methane in liquid form. We have methane here, but in gaseous form. Okay. So whenever you have methane, what you have to do? You don't have to do anything. You just have to light a matchstick, an entire planet will be in fire. So Uranus, we can have Happy Diwali on Uranus just by lighting a matchstick. Okay, that's for fun. That's only for fun. Okay, just to make it a little imaginative in your mind so that you can remember properly. Okay, it is unique. As its axis of rotation is inclined at 98 degrees. Axis of rotation is inclined at 98 degrees to the orbital plane. Now, a very important point. Unlike others means a special point coming up for Uranus. Unlike others, which spin on their axis. Other planets, they spin on their axis. But Uranus, my brother, Uranus is different. He's little hatke. And he's saying what? Uranus actually rolls. Uranus actually rolls apparently from north to south. Now that's a very interesting thing. See, every planet rotates on its axis. Like I told you yesterday, that Earth is not this like this. Earth is a little tilted. So axis of Earth is 23.5 degrees. Okay, so it is tilted. It is like this. So this, imagine this to be your Earth. This to be your Earth. North up, south down. Clear? So this is Earth, but Uranus, my boy, Uranus is, it doesn't spin. It rolls actually. For Uranus, north is not here. For Uranus, north is here. Okay, so north and south, and it actually rolls. So if this is sun, this planet is actually rolling. Okay, it is not spinning. It is actually rolling around the sun. So that is the beauty of Uranus with its methane atmosphere. Okay, with its methane atmosphere, Uranus is actually rolling. Okay, so and it rolls, and it is apparent. It rolls from north to south. So from north to south. So this should be actually north to south. So actually it rolls like this, from north to south. So this is how it is going around the sun. Around the sun, it is going like this, north to south, north to south. Okay. Now we drank some water from Uranus. All right. So, okay. So next point is, for rotation, it takes around 17.2 hours. Again, less than 24 hours. Less than 24 hours. And it takes around 84 years for rotation, for revolution. For revolution, 84 hours, 84 years. And for rotation, 17.2 years. 17.2 hours. I beg your pardon. When we talk about Jupiter, Jupiter also take around 9.8 hours or something for rotation. And for Saturn also 11 point something for rotation. And this boy is taking 17.2 hours for rotation. So you'll see outer planets actually taking less than 24 hours. Outer planets actually taking less than 24 hours for rotation. So they are quickly completing their rotation. But for revolution, obviously they'll take long time. Why? Because they have humongous orbits. They have a huge orbit. So they have to cover huge orbits, and that is why rotation, that is why revolution is a little longer. But rotation wise, which means they are spinning at an amazing speed. They are spinning at an amazing speed. Okay. And the inner planets like Mercury, Venus, we are lazy planets. We are lazy. Only Earth is doing well. Only Earth is doing well. Earth is just completed 25. But others are lazy planets and they are going very slow. All the inner planets, they're rotating very slow. Okay. So we're joined by Muskan. Okay, Muskan, very good morning to you. Welcome to the session. May I know the reason why you're not present in the current affairs session? Because you should be present in the current affairs. Any specific reason? And I would like to know if there is something you want to share. Okay. It is surrounded by a system of 9 faint rings. So I told you Uranus also has rings, Neptune also has rings, but they are very, very faint. Saturn has a ring system of 8 rings and they are very prominent rings. Okay, so but Uranus also has ring system, but 9 faint rings. Okay. It has 27 satellites. The most prominent are Miranda, Ariel. The most prominent are Miranda, Ariel. It has 27 satellites. So you'll find a lot of satellites for outer planets. Okay. 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 So Muskan, have fun, enjoy. Okay. So Phobos and Deimos for Mars, Moon for Earth. So we inner planets, we have very less number of satellites. 1, 2, absolutely none in some cases. But in outer planets, they have very high rotational speed and they have a high number of moons. Okay, so this is one point. Always remember, they have high number of moons. So 27 satellites, and out of which Miranda, Ariel are the prominent ones. So all these, theory part, we can cover later on. All this theory part we can cover on later on. But it is not important to remember everything. What we just have to remember the important points. For example, when I say green for Uranus, you automatically understand it like green color. Green color. Next point, methane. Methane in atmosphere. Methane. Okay. Okay. So what next? Rolls from north to south. Rolls. What it does? It actually rolls. North to south. So it goes like north to south. Okay. Then we have Uranus was discovered by William Herschel in the year 1781. So a person's William Herschel's name is given and 1781 is given to you. Okay, clear? Uranus has 27 known moons. Yes, we already spoke about that, 27 satellites. The axis of Uranus lies almost parallel to its orbital plane. The axis of Uranus almost lies parallel to its orbital plane. Yes, parallel to orbital plane. We all know that. I told you this is not south. It's actually rolling this. Like, correct? This is the orbital plane. This is north of Uranus. This is south of Uranus. So it is going like this. Okay, it is going like this. Which means that the planet spins nearly on its sides. It spins, it rolls, yes. Which earned the planet the moniker, the planets on its side. The planet on its side is called as, which planet known as planet on its sides? Uranus. Uranus is planet on its side. Okay? So, planet on its side. Okay. So, the entire Uranus is actually in 4 points. Actually in 4. So there are 4 keywords. So entire board, what you can see on in the entire board, the entire thing have been summarized into 4 important keywords, 4 into points, and those 4 important points are can be your potential questions. Can be your potential question. Green in color, methane atmosphere, rolls north to south, planets on its side. Okay, 4 points. Uranus is done. Okay, so you have to segregate everything in points. Clear? All well, all set? Okay, this is done. Let's see the next one. Let's see the last one. Last planet. Okay. Okay, so Neptune. So we talk about Neptune. Neptune is the farthest. Yes, of course. We all know that Neptune is the farthest. Mercury is the nearest one. So nobody is going to ask you which is the farthest, which is the nearest one. It's common knowledge. It's very, very understood, very basic things. You won't get such question in there. It's just for your understanding. It has a dynamic atmosphere which contain an Earth-sized spot called Great Dark Spot that is similar to Jupiter's red spot. Okay, okay. So very important point. Great Dark Spot. We'll write here. Great Dark Spot. Great Dark Spot. Where is a Great Dark Spot? Great Dark Spot is on Neptune. It's on Neptune. And Neptune has a great great dark spot, much like we have giant red spot where Jupiter, on Jupiter. So giant red spot for Jupiter, great dark spot for Neptune. And this one is similar to the spot on Neptune is similar in size to Earth. But Jupiter one is much bigger than Earth size. Clear? Do not get confused. So great dark spot. Yes, one important point we have taken from this one. It has 5 faint rings. Again, I've told you we have ring system. We have ring system for big gaseous planets, outer planets, but they are very, very faint. Only Saturn's ring system is much prominent. Neptune and Uranus is much fainter, like 5 faint rings. It appears as vivid in blue in color. Okay, so we have another one with color based. So Neptune is vivid in color, vivid blue in color. Okay. So Neptune is vivid blue in color. Okay. So color is clear to us. Great dark spot is clear to us for Neptune. It takes 165 years for revolution. Obviously, very, very long, very, very huge, very, very big orbit. It's gonna take 165 days, understandably so. But look at this boy, look at this chap, but look at this fellow. Just 16 hours, not even 24 hours. Just 16 hours takes for one rotation. So it quickly, it just rolls. Sorry, it just on its axis, it just spins so well. In just 16 hours it completes. And small planets like Earth, like Mercury, and others, we take long time. We take 24 hours. Earth is taking outer planets, they are taking 16 hours. So one thing is very clear to us: outer planets take very less time for rotation. For revolution, obviously they have big orbits to cover, so they do take that time. And they have a ring system, all of them. Okay, faint, prominent, depends. And they have high number of moons, satellite. Okay, for big planets. So this is a common feature and a very distinguished feature from the inner planets. Total number of moons is 14. Not a big number, not a big number by an outer planet standard, not a very big number. But when you see from inner planets, it's pretty big. Okay, so 14, and the prominent ones are Triton and Nereid. Okay, so we've gotten the name of two moons. Triton. It's Triton and not Titan. Titan is for Saturn. Okay, they're two different things. Triton and Nereid. Okay, so great dark spot, vivid blue, Triton and Nereid. Okay, Neptune is very similar to Uranus and can be considered its twin. Okay, so we have another set of twins in the family. We have one set of twin in the family as Earth and Venus. And then we have a family of a set of twins of Uranus and Neptune in the family. Okay, so they are similar in size. If you have seen the image that I showed you in the previous class, they are similar in size and density. Okay, so Neptune is Uranus brother or twin. Clear? So these are clear to you. If it is clear to you, you can just give the thumbs up in the chat section so that I get to know that I am not the only one speaking in the class. You guys are actually listening to everything that I say. Okay, so Kanak, Amrita, and others, student prepare. So if you are listening to me, you can just give me a sign that you are listening to me. Otherwise it becomes very monotonous. Okay, so got a thumbs up from Kanak. So Kanak is listening to me. Good. Amrita, what about you? So yes, so Amrita is giving me 6 thumbs up. Okay, good, great one. Chalo. So everything is clear to you. Superb. So now the major question that is in the minds of everyone is what? Pluto is not a planet anymore. Why? Why our brother Pluto has been kicked out of the family? Why he has been kicked out of the family? Because Pluto brought us shame. Pluto brought us shame. Why? See, Pluto was discovered by Clyde Tombaugh in 1930. Pluto was discovered by Clyde Tombaugh in 1930. So remember the name whenever we have the names of people discovering something. So this is important. And before we speak about the reason, I want to tell you something. Pluto, guys, Pluto is not the name. The name of the planet Pluto is not inspired or derived from the name of a Disney character, that Pluto dog. It is not taken from the Disney character. Okay, most people think that way, but it is not the case. Pluto in Roman mythology, it means god of underworld. Okay, and by underworld, I'm not suggesting the Mumbai underworld or the Dawn underworld. That no, it's not about that. Underworld means, in Hindi we say Patal Lok. In Hindi we say Patal. Okay, or in very loose language, if you want to understand, hell. Okay, so god of underworld. So who is the god of underworld? The god of underworld is Pluto. In our case, we say god of death is Yamraj. So mostly like that. So Yamraj. So mostly like that. Okay, so god of underworld is Pluto. And Pluto, why it is called Pluto? Why did we call it god of underworld? Because Pluto is very far away from us, very far away from sun. So understandably, there is no sunlight. Sunlight doesn't reach that far, So no sunlight, and very cold. So no sunlight, so no heat. Very cold. So it was understood to be very cold, very dark. Okay. But recently NASA sent a mission called as New Horizons mission, and it was a flyby, it was a fly past. So Pluto, and it was made in such a way that if this is the mission from NASA and this is Pluto, so it will fly very close to Pluto, not so close to Pluto that Pluto will attract the mission into its because of its gravitational field, but just enough so that enough pictures can be clicked of Pluto. So first time in the history of mankind we have pictures of Pluto available on the internet. So proper pictures received by NASA. So it was uploaded by NASA. So NASA has some photos. So there is some land in the pictures. In the pictures, it appears more like reddish and pinkish. So soil is very nice. We don't know why because it's pink, but it looks little pinkish and reddish, the soil. And there is a picture, and we can see a land, a rock, and something on the land on the surface of Pluto, which looks like a heart. That heart emoji, it looks like heart. And people have commented on the internet that even Pluto has a heart. Okay, do not kick Pluto out. So even Pluto has a heart. It was a big meme that happened. Okay, quite some time. So after the class, you can go on Google and can watch pictures of Pluto. It's very interesting. Okay, so this was story about Pluto. Now what happened to Pluto? Why Pluto was kicked out? Why Pluto was kicked out? Because the definition of a planet by International Astronomical Union. So we have a union, an organization called as International Astronomical Union, that defines what is a planet and what is not a planet. So according to their definition, in 2000 they made this definition: a planet in solar system, any heavenly body or celestial body, is called a planet only when three conditions are satisfied. Number one, it should be in an orbit around the sun. Was Pluto around an orbit? Yes, definitely it was. Sun was in the center. If this is Pluto, Pluto was revolving around the sun. Pluto was very much attracted and attached by the gravitational pull of the sun. It was not going. It was not moving haywire. It was properly in an orbit and revolving around the sun. Yes. So first condition was satisfied by Pluto. Yes, it was. Second, has the sufficient mass? It is not mass. Okay, has the sufficient mass so that it assumes a planet-like geoid shape, which means it should. Did Pluto had a geoid shape? Geoid shape is actually planet-like shape. Geoid shape is planet-like shape. Okay, and you might ask, what is a geoid? What is a geoid? See guys, a geoid is, imagine a ball. Imagine a tennis ball in your hand, and you're holding the ball exactly like this, thumb down and two fingers above. Okay, index and middle finger above and your thumb down. So you're holding a ball. Now what do? You press the ball a little. You press the ball with your thumb and your two fingers. You just press the ball. What will happen? The ball will get pressed from the very bottom and from the top position, from where you have exerting pressure, and that way. And the bottom and the up part will go inside, and the equator part, or at this side, this part, this part. I'll draw a picture. If this is the ball, so you're applying pressure here and here, and this will move a little out. This will move a little out. Yes, correct. If you press the ball, it will move a little out. So it is flattened at the poles. A geoid is flattened at the poles and bulged at the equator. Flattened at the poles and little bulged at the equator. So if you have such a shape, you are a planet. Okay, you are a planet. So that's what the definition. Did Pluto have such a shape? Yes, it did. Yes, it did. Pluto does have such a shape. Pluto does have a geoid shape. So this is also satisfied by Pluto. So 1 and 2 conditions were satisfied by Pluto. But what about the third one? Now the problem is, the third is, does he had cleared the neighborhood around the orbit? This was not satisfied by Pluto. Which means okay. So in the family, only sun can be the biggest one. Okay, and planets should directly be around, should be revolving around the sun. Now what was happening? I'll show you in the picture. While drawing a picture, how our brother Pluto was cheating us. How our brother Pluto was deceiving us. What happened? See, if this is sun, and this is Pluto's orbit. Okay, we'll say P. So this is Pluto's orbit. So Pluto was going around the sun like this motion. Okay, let's say if it is this motion. Now, what was actually happening? There is a big asteroid. Okay, a big object, bigger than the Pluto. There is a big object, object bigger than the Pluto in the neighborhood. Let's just call it X. Okay, in the neighborhood of Pluto, very near to Pluto. So what was, and that object is also under the gravitational pull of sun. That object was also under the gravitational pull of sun. So what was happening, guys? What was happening? Pluto was not revolving around the sun. Pluto was actually revolving around that object X. If you can see in the picture, if that is clear to you, okay. Pluto was actually revolving around that object X. So this was the case. Pluto was moving around that object X, and that object X was moving around the sun. So Pluto was cheating us. The Pluto, our brother from the family, okay, brother from another mother. He was cheating us. He was deceiving us. So we found out, and when we found out, we kicked the Pluto out. We kicked the planet Pluto out of our family. Now Pluto has been degraded to a dwarf planet. It had a royal status. It had a royal status of a planet. Now it has been, the status has been lowered. The status has been lowered. So now it is a dwarf planet. Clear? I think it is clear. If you understood it, give a thumbs up in the chat session. So I get to know that you understood the entire story. Okay, if you understood it, just give a thumbs up. So I get to know. Because in the classes, it is very difficult to understand whether you are, whether everything is clear to you or not. So that is the only medium I can ask, where to just tell me if it is all clear to you or not. Okay, if it is all clear to you, Kanak is giving a thumbs up, and if you like the story also. Okay. So I know, Amrita, Kanak, you guys are hurt. You guys are hurt because of the actions of Pluto. I know, we all are hurt. We all are hurt, but nonetheless, such is life. Okay, we have to move on. Clear? So all set, all clear. Chalo, this is all done. So third condition is not cleared, not passed. So Pluto was moving around a bigger object, and that bigger object was moving around sun. So Pluto was not directly moving around the sun. It was actually around a planet, something else, an asteroid. Clear? So this is done. In reality, actually, Pluto is very, very small. Pluto was an exception when you talked about outer planet. It was not a big, it was very small in size. It was probably equivalent to Mercury. Okay, so done. Chalo, we'll move to next one. Okay, so now we spoke about the planets. So planets all clear. Now we'll talk about asteroids, other heavenly objects. Okay, so when we talk about things that are in our solar system, the highest respect is accorded to the sun. Sun gets the highest respect. Then after sun, his wife Moon gets the next respect, and then the planets, they get respect. So number 3 are planets, and when planets are done, all the kids, planets are the kids. So father is your solar system, the father is your sun, mother is Moon, and the kids are the planets. So after the kids, we talk about the other people, the other relatives in the family, the cousins. The cousins are asteroids. Okay. So what is basically an asteroid? Asteroids are basically big chunks of rocks, and let's just say there's a theory called Big Bang theory. I'll explain that time. So asteroid actually big chunks of rock. Some of them are 100, some of them are 100, 500, 800,000 kilometer wide. Can you imagine 1,000 kilometer rock coming down on Earth? That would be much, a scary situation. So big chunks of rock. So big chunks of rocks, and in some people also call them failed planets. What is a planet? What is Earth? Earth is like, actually, if you see, it's a big rock. It's one of the big rocks. Correct. If you drain all the water, water from the oceans, what is at the bottom? What is at the ocean floor? Again, rocks. On the surface, rocks. Below the ocean, rocks. There are rocks everywhere. So what is Earth? The Earth is actually a very, very massive rock, a big rock. So similarly, scientists call asteroids as failed planets. Asteroids are probably this shape. They are random shapes. They are random shapes. So asteroid, if it was in a planet like geoid shape, it would have become a planet. Okay, it would have become a planet. So for planet, we need those three conditions to be fulfilled. Clear? Okay. So big chunks of rock. Asteroids revolve around the sun. Yes, they also revolve around the sun. And just to tell you, there is there is so we have Earth, we have Mars, and then we have Jupiter. Right? This is the arrangement. So there is an asteroid belt that is present between Mars and Jupiter. So there is an asteroid belt that is present. So there is an asteroid belt. So these small dots, they depict your asteroids. So what asteroids are doing? They are just floating. They are under the gravitational pull of the sun. They are under the gravitational pull of the sun, and they are just floating. Okay, they're just floating, and not just floating. They're also colliding among themselves. They are, there is constant collisions happening. So we have this rock. They have another asteroid coming and it's colliding. So when two big chunks of rocks they collide, what you get? You get smaller rocks. You get smaller broken up rocks. Okay, so then they also collide, and then we have other things, and they are moving at a massive speed. Okay, do not understand it to be floating like casually. No, they are going around like zoom, like few 1,000 kilometers an hour per second, 1,000 kilometers per second, plus more 1,200 kilometers per second. So they are zooming past. When we have satellites, we are very scared of asteroids. We are very scared of asteroids because these smallest, if you have a 5 mm particle of rock and it is going at a speed of 1,000 kilometers per second, it can cause huge damage. So we are very scared. International Space Station, satellites, we all are very scared of all this, and they are floating like this. They have they do not respect boundaries. They are floating everywhere. Okay. Yes. Excuse me. Amita, very good point there. So we can also say that we have inner planets here. I'll say IP. We have outer planets there. We say OP. So what is between inner planets and outer planets? It's an asteroid belt. So we can also say asteroid belt separates. Okay. The inter. Yes, Kanak has made a very good point, and Kanak, I was coming on that point next. Now, very important point Kanak mentioned. Let me talk about it. Guys, as I told you, what an asteroid? Asteroid is a failed planet. That means an asteroid has the same composition as of a planet. Just not the shape, but same composition, same metals and everything. So, Kanak is absolutely right. Asteroids even have deposits of gold, of rare earth metals that we need on the earth. So gold is one for ornamental purposes, basically, mostly. But other metals which we use in laptop, which we use in chips, in semiconductor devices. So all those asteroids are filled with that. And just to add to this information, we have billionaire group. Google's co-founder Sergey Brin has made an attempt. They are forming a company which will go on and which will identify an asteroid first, which has abundance of metals which are not found in India, not found on the earth, or are found rarely, or are controlled by some other countries. So they are planning to send missions to asteroids, different nearby asteroids, and do the mining there. Okay, can you imagine, taking gold from an asteroid, taking rare earth metals from an asteroid, and getting them all filled up in the spaceship and coming back to Earth and using them for their own benefits. So and if they're able to do it, they will become world's first official trillionaires. Not millionaire, not billionaire, but trillionaires or quadrillions maybe. Okay, so the kind of wealth that we have never seen on the earth. Okay, so Such as I told you, universe is one thing. Yes, Amita saying amazing, sir. Exactly, I was also amazed when I learned about this. So universe is one thing. There are amazing twist and turn in every single point. Every single point is baffling information with it. Amazing points. Last time I told you there is a huge planet which is entirely made of diamond because of the extreme heat and pressure that planet underwent. See, entire thing of diamond. So they are amazing things. Okay, some very scary things also. Okay. Okay. So next one is. Okay, so there is an asteroid belt mainly found between Jupiter and Mars. Yes, so there is an asteroid between mainly found here. So we can say that. Okay. Next is asteroids are rocky bodies that fail to form as planets. Yes. So point number 3, as I already explained to you. So they fail to become planets, but they are the same combination, not the shape, but everything else is same. Okay. So asteroids may be irregular, elongated, or spherical in shape. So they have random shapes. So they have random shapes. All right. So they have random shapes. So it could be irregular, elongated, spherical, or no shape, or no proper shape. Okay, no proper definite shape, anything. Okay. Okay. So these are asteroids. Basically, these are asteroids. Done. All clear. All set. We move next one. So asteroid is all clear to us. Asteroid all clear to us. Okay. Okay. Yes. So next thing we're talking about is meteors and meteorites. It's going to be meteors and meteorites. So you all must have known or heard about meteors and meteorites. I'm very sure about it. Okay. Yes. So Kanak is saying yes. So we all know about meteor. But what is the difference, or what is the main difference between a meteor and a meteorite? We'll talk about that as well. Okay. See. When two independent asteroids collide, we get smaller fragments of asteroid. Clear? I told you this. So we have huge asteroids coming and colliding. Okay, so one is going other way, the other one is going other way, and then this. There are no traffic signals, so everything is haywire. So those asteroids are just colliding, and small asteroids are forming. So what happens? When these smaller fragments of asteroid pass close to Earth? Earth pulls them. Now, what is happening here? See, what is happening here? Understand this way. Okay, so we'll make use of this picture. So what is dot represent? They represent asteroid. Now, guys, what happens? See, this is asteroid. Let's just say this is asteroid 1, and this is asteroid 2. Okay, so asteroid 1 and asteroid 2, so they are minding their own business, and suddenly they come and collide. So smaller fragments of asteroid will be born. So what happened? Let's just say asteroid 2 came and hit asteroid 1 with huge force, and a big chunk of rock. A big chunk of rock is broken off from asteroid 1. It's broken off from the asteroid 1, and let's just say this is smaller chunk of rock. We'll make it from a different color. We'll make it blue. Okay. So this is asteroid. Let's just say asteroid A0. We'll talk asteroid A0 or asteroid 3. Chalo, for convenience, we'll call asteroid 3. It's a new asteroid. Now what happens? This asteroid is taken off. It is no longer in that particular belt, because it was struck with so much force that the broken off goes out. So it is traveling because it is going out, but still under the force of sun. Now what happens? Earth is also coming this way. This asteroid is also coming this way. Okay. Now what happens? As this asteroid comes closer to Earth, or Earth comes closer to this asteroid, Earth's gravitational pulls the asteroid in. Earth's gravitation force pulls the asteroid inside. Inside what? Inside its atmosphere. Okay. So asteroid was going, Earth was coming, and suddenly Earth saw an asteroid like, come to me. So it is pulled. So Earth attracts because of gravitational pull. That asteroid is attracted or pulled inside. Clear? Attracted or pulled inside. Now what happens? When these fragments, smaller fragments, asteroids pass close enough to Earth, the gravity of the Earth pulls these fragments into its atmosphere. So they are pulled in. So now it was called an asteroid, correct? It was asteroid A3. Now when it gets pulled by Earth inside, and when it enters the atmosphere of the asteroid A3 or any asteroid, when it enters the atmosphere of Earth, we call it, the name changes, the place changed. Earlier it was in the belt, not in atmosphere, but different place. As the place changes, the name changes. Clear? Now it is called an asteroid. Same stuff. Now it's called a meteor. Same stuff, same composition, everything same. But now place has changed. It is in Earth's atmosphere. It has entered. We'll call it meteor because it is doing a different function now. It has entered in our atmosphere. Now it's called a meteor. Clear? All set? Amrita, all set? Kanak? All clear? So now same thing, different place, different name. So it's called a meteor. Now what happens? Now Earth has pulled it inside. Earth has pulled it inside. Lekin, but one is, yes, Kanak, yes, Kanak is correct. Another, yes, asteroid that come, and Amrita saying good, great. So now guys, what happened? What is happening? So guys, Kanak is saying all clear. Thank you, Kanak, for the answers, because when you guys reply to me, that means you are also engaged at the same enthusiasm level I'm teaching. So it is a two-way street. It feels nice. Thank you for that comment. Okay, so meteor. So it's a meteor when it enters. So it's an asteroid when it enters. It's meteor. Now what happens? Now it's a different scene. Now Earth is pulling it. Now imagine this is the Earth and this is the atmosphere of the Earth. Now asteroid is meteor. So meteor M1. We'll call M1. So now meteor is attracted, coming towards. Now what we are welcoming, the Earth is very smart. Earth has attracted. It has called the asteroid. Asteroid, come to me. So asteroid is coming to it. It has become meteor now. Now Earth is welcoming the meteor. Earth is welcoming the meteor with air resistance. Okay, because it is not a smooth sailing. It is not smooth sailing. So the meteor, it collides, or it passes through air. So we have air resistance. Because of air resistance, because of friction offered by air, the meteor catches fire. The meteor blows. It doesn't blow up, but it catches fire because of high resistance offered by air. So now we have seen that we sometimes call it shooting star. We sometimes call it shooting star, or in Hindi we say tootta tara, right? Shooting star, which is glorified in Bollywood, okay, and in Indian movies. If you see a falling star or a shooting star, you just pray something. There's no logic behind it. Okay, so it all burns up because of the resistance offered by the air. So it is burning up. It is burning up, and let's just say if it burns up, it entirely burns up. Before it touches the ground, the entire meteor is burned up in the atmosphere, then it was gone. Okay, it is not called anything else. That's if it comes down, and the meteor is also very resistive. Like, I will touch the ground. I was called by Earth. I will touch the ground. Okay. If that is the case, if meteor is big enough, it is very big meteor, and it doesn't burn up completely. If it touches the ground, the name changes. Now the name changes once again. Now it is called a meteorite. Now it is called a meteorite. So meteors previously were asteroids, and meteorites were previously meteors. So meteor, if it gets burned up, we are not talking about any further, but that meteor is very, very resistive. And it's very like, I was called by Earth, I will touch the ground. How dare she calls me and burning me up? Okay, so I will touch it, I will hit the ground. Okay, and if it manages to hit the ground, then a new name is given to it, and it is called a meteorite. Okay, and there is a very small trick I want to share with you to remember the difference between the two. See, whose journey was smaller? Meteor's journey was smaller because it got burned up. Whose journey was bigger? Whose journey was longer? The longer journey was of meteorite because it managed to touch the ground. Because long journey, so managed to touch the ground. So, bigger name for bigger journey. Bigger name for bigger journey. It's very simple. Okay. Bigger name for bigger journey. Smaller name for smaller journey. Clear? Yes, Amrita is saying Meteor got fooled. Yes, Meteor got fooled by Mother Earth. Our Mother Earth is very smart, okay? And Kanak, okay, haha, okay. So I enjoy. So you guys are enjoying it? So superb. Yes, all clear. Amrita is saying all clear. Kanak is saying all superb. Alright guys, so this was the basic difference between a meteorite, a meteor and an asteroid. I'm sure you must have heard the terms a lot many times, but you were never sure what is the difference between the three. So this is the basic difference between the three. I hope it is clear to you. Okay. So if it is clear to you and you really enjoyed it, so just let me know that you understood it. Yes, Amrita, meteorite. So bigger journey. And just one last fact I want to share with you. There have been a few instances where a meteorite was able to touch and hit the ground. And long back in India, it happened in India. Long back, when India was, Amrita's giving a thumbs up. Thank you, Amrita. So long back when India was inhabited by dinosaurs. Yes, there were dinosaurs in India. Okay, dinosaurs in India. So there is a place called Lonar. There's a place called Lonar in Maharashtra, and a big depression was created. A big crater was created because of the meteorite impact, and over time, because of the rain and everything, it got filled up. Now it is called Lonar Lake. It is a meteorite. It is a meteorite lake. It was formed after a meteorite impact. Clear? So this is an example of a meteorite lake. It is in Maharashtra and it's called Lonar Lake. Clear, guys? So with this, we come to the end of the session. Okay, so meteorites, meteor, asteroids, Neptune, everything is cleared. Okay, so I hope you had fun. In my opinion, studies are supposed to be fun. Learning is supposed to be fun, and it should be fun. It shouldn't be stressed. It shouldn't be stressful at all. If you're learning, if you're having fun while learning, you will remember, you will retain it for a much longer duration, and you will happily reproduce that in your examination. Okay, so examinations are not supposed to be taken any kind of stress. It's more fun. So, okay, everything is fun. You just have to be in a right spirit. Okay, chalo. All right. So Amrita giving thumbs up, Kanak giving thumbs up. So thank you guys for joining in today. Okay, so tomorrow, Sunday we have weekly revision 10 to 11. 9 to 10. So 9 to 10 would be your weekly revision. Thank you, Amrita. Thank you, Amrita. All right. Bye-bye, guys. See you tomorrow. And it would be a recorded session, so kindly watch it. Entire week's current affairs shall be revised. All right. And I see you guys on Monday. Current affairs again. Same time, same place, same channel. Till then, take care. Keep studying. Thank you, guys. Bye-bye. Take care.